Let's review how to find inverses. Here are the 4 steps. Most functions begin in function notation, and that's why we want to begin by rewriting it as y equals. So in example 1, instead of f of x, I'm going to write it as y equals 3x plus 5. Step number 2, switch your x and y variables. So it becomes x equals 3y plus 5. Step number 3, solve for y. So to solve this equation for y, I'm going to subtract 5 and divide it by 3. And then the last thing we want to do is put it in inverse function notation. And the way we do that is by replacing our y value, replacing y with f inverse of x. And that is how you find the inverse. This is my inverse function right there. So let's practice with a few more. So let's look at example B. First step, replace f of x with a y. Second step, switch x and y. Third step, solve for y. I need to square both sides in order to eliminate the square root. And then I am ready to add 4 in order to solve for y. And our last step is to put it in inverse function notation. Replace the y with f inverse of x and write your function. In example C, we're going to do the same. Y equals negative 16 plus x cubed. Switch our x and y. Add 16. And now this is y cubed. So we have to take the cube root. Cube root and a cube, they're inverses, like a square root and a square. So my function is the cube root of x plus 16 equals y. And when I put that in inverse function notation, I have f inverse of x equals the cube root of x plus 16. Let's do that with a few more. Feel free to pause the video at this time to see if you can get the correct answer for question D. So if this is what you got, you are correct. F inverse of x equals negative 1/3 x plus 6. Now I did simplify this. So if you got x minus 18 over negative 3, that is the same answer, and I would accept that, but realize that if it's a multiple choice question, the answer will be simplified. So what I did was I separated this into 2 fractions, and I wrote it as x over negative 3 plus negative 18 over negative 3. And that's how I got my simplified inverse function. Let's look at example E. Now, this is your domain restriction. Okay, and this is not going to be used when you're finding the inverse. The reason why we have a domain restriction is because the inverse of a quadratic is a square root, and a square root has a limited domain. Don't worry with this at this time. This is only there because the inverse without this restriction would not be a function. Going back to what we learned about one-to-one. Because a quadratic is not one-to-one, the inverse is not a function. So we put that restriction there, but you don't need to use that restriction when you're finding your inverse. So again, I'm going to begin with replacing f of x with y, and then I'm switching my x and y, and I'm going to solve it for y. Subtract the 5, divide by -3, and again I'm going to write that simplified, -1/3 x plus 5/3 equals y squared, and then our last step is to take the square root. So my inverse function will be f inverse of x equals the square root of -1/3 x plus 5/3. Our last function is a rational function, finding the inverse of a rational. So I'm going to switch my x and y. Now notice that because x appears in more than one spot, I'm going to have to put that y 2 different places. And now we need to solve this for y. So how are we going to do that? Well, in order to do that, I need to get both of these y's. I need to reduce that down to, or simplify it down to just one y in one place. So I'm going to begin by cross multiplying. So I multiply x times y and 1 times 4 minus y. And then I'm going to add that y to the other side. That way I have my y's on the same side of my equation. So when I add the y, I have xy plus y equals 4. So now I can factor out a y. And when I factor out the y, I have x plus 1. And in order to get the y by itself, I'm going to divide both sides by x plus 1. So my inverse would be y equals 4 divided by x plus 1. Or inverse function is 4 divided by x plus 1.